During this video, you will learn how to compute the information score. Together with the calibration score, the information score objectively measures the performance of experts' assessments. Unlike the calibration score, which is computed by taking into account expert assessments on all calibration questions, the information score is computed for each calibration question separately. Let's take an example of one calibration question. Suppose we have 3 experts' assessments for the maximum temperature in Delft today. You can see the experts' 5%, 50% and 95% quantiles on the slide. Now, suppose we wait until the evening and notice that today was an unusually warm day for this period of the year. And the maximum temperature was actually 16 degrees. So, we say that the realization, or the true value of this calibration variable, is 16. To compute the information score of each expert for this calibration variable, we first need to determine the intrinsic range, or the support of the variable. That is, we need to obtain bounds which are determined by expert assessments and the realization. For this, we first take the minimum between all the 5% quantiles and the realization, which is the minimum between 7, 6, 8 and 16, and that is of course 6. We also consider the maximum between all experts' 95% quantiles and the realization, which is the maximum between 15, 10, 11, 16, and that is 16. We define now the interval LU, which is determined by the minimum and the maximum value, which is 6, 16 for our example. The support, or the intrinsic range, is then determined by extending the interval LU by an overshoot k times the length of the interval LU, where k is typically chosen to be 10%, or 0.1. The intrinsic range, L star U star, is given by this formula. For our example, the length of the interval is 10, that is 16 minus 6, so the overshoot, that is k times u minus L, is 1. We get L star U star, the interval, as 517, and this is the intrinsic range for our question. Remember that this will be the support of this calibration or seed variable. This support is then used to construct expert distributions, as you have seen in the previous video. For each expert, denote the 3 quantiles as Q5, Q50 and Q95. The information score for a given question J is computed with this long formula. That depends on the 3 quantiles, but also on L star and U star. Again, Ln is the natural logarithm here. For our example and for expert 1, recall the 3 quantiles, which are 7, 10 and 15. By plugging these values in the formula, we get that the information score, rounded to the 3rd decimal, is 0.179. Similarly, by applying the formula with expert 2 quantiles, we get an information score of 2.84. Finally, the information score of expert 3 is 1.03. Check these results yourself. Here are the information scores of all 3 experts. We know that the higher the information score is, the more informative expert assessments are. We see that expert 2 assessments are the most informative, whereas expert 1 assessments are the least informative. Finally, it should be mentioned that intuitively the information in expert assessments is the degree to which the distribution is concentrated. Have a look at the assessments of the 3 experts and see that indeed the experts 1 assessments are least concentrated and the experts 2 assessments are more concentrated than the other 2 expert assessments. Bear in mind though that this is just an intuitive check and should not be replaced by the actual calculation of the information score. Also, the information score is measured with respect to a background measure or reference, which is chosen by the analyst. The background measure is either the uniform or the log uniform. In all the examples that you have seen or will see throughout this course, we will use the uniform measure. The motivation of these choices is that they are the least informative available measures, and any information should be quantified with respect to this least informative background. We computed the information score for an expert for one single seed variable. To get an overall information score for an expert, we need to account for the information score in all of the calibration questions. We do that by averaging information scores obtained for all questions. This formula is given for m questions. You will later use this formula to compute the information scores of various experts. You have now learned about the second score that is used to objectively evaluate experts' performance. Thank you for your attention.